Alright guys, welcome to this page of the notes. Now what we're going to do is work on solving a problem using Cramer's rule to solve a system of three equations. Now like I said, what I've done, because these are fairly long problems, is to save a little bit of time. I've already worked out the solution. Let me just run through it with you real quick so you can see where my numbers come from. Again, you should just be checking your answer with mine. Hopefully you've already had a chance to run through it. Right away, we recognize that in my system of equations, I'm missing a couple of variables. So I rewrite my system with the 0z and the 0y, rewriting my three equations, right? Because if I'm missing a variable, I have to put in a placeholder. Once I put in those placeholders, I write my coefficient matrix. Well, that coefficient matrix is now going to contain all of the coefficients, including my placeholders. So there's the 0 there and the 0 there that are holding the place. To find the determinant, right, of a 3 by 3 matrix, we're going to use the diagonal method, which means I rewrite those first two columns outside of the bars around my determinant. Diagonal method to take care of this. Just be real careful with your multiplication, that you are careful of your signs. Don't fat finger something on your calculator when you're doing those calculations. I wind up with a -1 being my bottom number and a -4 being my top number. Of course, it's bottom minus top. So -1 minus a -4. Careful, watch your signs. I get a determinant of a +3. That is now going to be the denominator in all of my calculations for finding the value of the variable. So let me go ahead and slide this guy up here a little bit. You can still see my determinant. I'm going to solve for x first. That 3 goes in the bottom, and I set up my determinant. But be careful, I'm solving for x, which means the 1, the 2, and the 1, I can't use those coefficients, right? I replace that 1, the 2, and the 1 with my constants. Well, these are my constants right here. 3, 1, and 3, right? Or 3, 1, and 3 in your new equation. So that's exactly what I put in. 3, 1, and 3. Everything else stays exactly the same, right? -2, 1, 0, -2, 1, 0, 0, 1, 1, 0, 1, 1, right? I'm just replacing the x coefficients with my constants. To find the determinant, rewrite the first two columns outside of the determinant bars, and then do your multiplication. Diagonals coming down, -3, diagonals going up, -2, bottom minus the top, I get -1, which means then that I have -1, the determinant of the top, divided by 3, the determinant of the bottom. So x is equal to a -1/3. Exact same thing happens for the y value. Again, though, this time since I'm solving for y, I replace the y coefficients. So instead of a -2, a 1, and a 0, I put in my constants, which remember was 3, 1, 3. So 3, 1, 3. Everything else stays the same. 1, 2, 1 for the x, 1, 2, 1 for the x, and 0, 1, 1 for the z, 0, 1, 1 for the z. Rewrite the first two columns, do your multiplication, bottom minus top, and -5/3. This one, I am going to do z with you. So let's go ahead and take a look at how this is going to work if we were to work through one together. So here we go. We're going to go ahead and find the value of z. All right. The 3 goes in the bottom, just like it does for all of them. That is the determinant of my coefficient matrix. Now remember, the one that's being replaced, right, since I'm solving for z, I replace the z coefficients with my constants, which was 1, 3, 1. So I'll do that in a second. But I keep the x and the y coefficients. So let me remind you real quick of what those were, right? 1, 2, 1, -2, 1, and 0. It's these guys right here, right? This column that gets replaced with my constants 3, 1, and 3. So here we go. Down here in the z, I'm going to have the 1. Oh, I'm sorry. Sorry. Need my marker. All right, so I'm going to have the 1, 2, 1. Those are my x coefficients. My y coefficients were the -2, 1, 0. -2, 1, and 0. And then the z coefficients get replaced with my constants. 3, 1, 3. my determinant bars and rewrite the first two columns. 1, 2, 1, -2, 1, and 0. All right, now I got to do my multiplication diagonal going down, which is going to get me a 3, a -2, and a 0, which should come out to be a +1. Now we go the other way. I get a 3 plus 0 and a -12. That comes out to be a -9. All right, well, now we do bottom minus top. So 1, careful, watch your signs. 1 minus a -9. Add the opposite. That's going to be 10. And z is equal to 10/3. So that's how it works. If you're going to work these out, right, you're just doing the diagonal method to find your coefficients. And these are my solutions, right? X is -1/3, Y is 5/3, Z is 10/3. You could write that as an ordered triple if you would like, right? So here's my solution. Writing it as an ordered triple, X -1/3, comma, my Y -5/3, and my Z 10/3. Now we are used to having seen nice, neat numbers coming out of Cramer's rule. Doesn't have to be. You can certainly get fractions. It'll happen. It'll happen. All right, let's go ahead and check out the next one. Again, what I've got for you here is a system of 3 equations. I've already gone through and solved this one for you. So again, we'll just run through. You should just be checking your answer. This is my coefficient matrix, just pulling the coefficients out of my equations. I'm not missing any variables, so I didn't need any placeholders. I find the determinant of my coefficient matrix by simply rewriting the first 2 columns outside of my determinant bars. I do my major diagonals, +417. Do my minor diagonals. Sorry, I actually forgot to draw a couple of those guys. There's that one. There's that one. And I wind up with a -204, which gets me a determinant of 621. Big old determinant, but that's okay. Certainly can happen. All right, here we go. Now I'm going to solve for x. So let me slide this guy on up a little bit here. Here's what I'm solving for x. The 262, my determinant goes in the bottom. I rewrite my coefficient matrix, but since I'm solving for x, I replace those coefficients with my constants, which were -14, 47, and 15. So that's why I have -14, 47, and 15 in that first column for the x's. Everybody else is exactly the same as my coefficient matrix. Do the diagonal method. Sorry, once again, I appear to have forgotten to put in my blue diagonals. Sorry about that. I wind up with a major diagonal, the product or the sum being 1,993, and the minor diagonals -1,112. Bottom minus the top, 3,105. 3,105 divided by 621, and I get 5. So my x value turns out to be a 5. We do the exact same thing for the y and the z. Again, I apologize. I forgot my minor diagonal lines. There you go. Again, once I get it all set up, I have to leave out the coefficients for y and replace them with my constants, which is y, -14, 47, and 15, right? Those are what my 3 equations were equal to, so those go in the y column. Rewrite my first 2 columns, do my minor diagonals, which I actually forgot to draw those arrows in there. I'm forgetting arrows all over the place. negative 2,460, negative 1,218. That gives me a determinant of negative 1,242. Divide that by the 621, we get negative 2 for the value of y. And once again for z, again the only difference here now is that z column. Leave out the coefficients for z, replace it with the 14, the 47, and the 15. I'm sorry, the negative 14. Negative 14, 47, and 15. And what we wind up with is 1,777. And in the top, negative 707. Looks like I forgot. Just make sure that you've got that minus sign in there for that 14. It's a minus 14, 47, and 15. 2,484 should be what you get for the determinant of the top. Divide by 621, and I wind up with a z value of 4. So my order triple, 5, negative 2, and 4 for this particular system of equations. Guys, thanks so much for taking a look at these problems with me. I have one more example problem that I want to look at with you. It's kind of something that's not going to show up a lot, but I do want you to know what to do with it if you see it. So head on over to the next page of the notes, and I'll meet you there.